This screencast goes over learning target 32, which is to use factoring to solve a quadratic equation. The big principle here we're working with is the idea of the zero product property, which says if I've got A times B equal to 0, then either A's got to be 0 or B's got to be 0. In order to make that happen, we have to first make sure we do have our equation equal to 0. Once that's done, we're going to factor it, and then we're going to set the factors equal to 0, and then we're going to solve. So that's basically the premise of what we are working through here today. So first example that we have today is 8x squared plus 3x is equal to 0. And in this particular problem, I have x's in both terms, but that's it. So I don't see a number that goes into both 8 and 3. I'm going to factor out the x. That leaves me with 8x plus 3 in the parentheses, still equal to 0. So now we can take one part and say x is equal to 0, or we can say that the 8x plus 3 is equal to 0. That x equals 0 part is already solved. The second part needs to be solved for x. We're going to subtract 3 from each side, and that gives me 8x equals negative 3, and we're going to divide each side by 8. So we have two answers, x equals 0, or x equals negative 3/8. Again, I could do that type of factoring because I had x in each term, and that was what they happened to have in common. Similar example to that would be to have 6x squared minus 30x is equal to 0. Once again, both terms have x in common, so I can factor that out. The highest number that goes into 6 and 30 is 6, so we're going to factor that out also. 6x squared divided by x, 6x is x, minus 30x divided by 6x is minus 5, equal to 0. Take my 6x equal to 0, or my x minus 5 could equal to 0. There's that zero product property again. Divide each side by 6 for the first half, x equals 0. Second part, I'm going to add 5 to each side, or x is equal to 5. And remember too, since it's an equation just like any other, you can substitute in and see that it works. Okay, normally our factoring is a little bit more complicated. We might be looking at something like this. X squared plus 2x minus 15 equals 0, where I can't factor out a GCF. So I'm going to go ahead and see, multiply number is negative 15, add number is 2. What adds up to negative, or multiplies to give me negative 15, adds up to give me 2. I'm thinking 5 and negative 3. Because it's an x squared, we can go directly to the factoring part, which says x plus 5 times x minus 3 is equal to 0. Apply that zero product property, and we've got x plus 5 equals 0, or x minus 3 equals 0. So we get x, we're going to subtract 5, and we're going to get that x equals negative 5. Or we're going to add 3 to each side, or x could equal 3, and again, I've got two possible answers here. Similar type of factoring problem, x squared minus 5x minus 14 equals 0. Again, I'm looking for two numbers that multiply to give me negative 14, add up to give me negative 5. I think negative 7 and 2 are going to work, which gives me the factoring of x minus 7 times x plus 2 equal to 0. Like we've been doing, take each individual factor, set it equal to 0. And we're going to add 7 on that first set to give me x equals 7. On the second part, we're going to subtract 2. It gives me x equals a negative 2 there. Okay. Continuing on, getting to factoring maybe it's a little bit more complex. Let's maybe look at 2x squared minus 9x minus 5 equals 0. Again, setting up my x, my multiply number is negative 10. My add number is negative 9. That's going to be negative 10 times positive 1. Moseying on over to the box. 2x squared. Splitting apart that 9x as a minus 10x. Sorry, negative 9x as a minus 10x. And plus a 1x and minus 5. Going down, two terms have x in common, and the second two terms have a minus 5. Need the minus because of the minus 10. Across, first two terms have 2x in common. Second two terms just have a 1. It's got to be positive, so we put plus 1. So this factors into x minus 5 times 2x plus 1 equal to 0. Take my x minus 5, set it equal to 0. Take my 2x plus 1, set it equal to 0. solve the first one for x by adding 5, and that gives me x equals 5. The second one, we're going to subtract 1 first, which gives me 2x equals negative 1. Divide by 2, and that gives me x equals negative 1/2. And remember, we do want to leave that answer in fraction form. Now, it's not always started to be equal to 0. Maybe I might have something like this. 12x squared plus 17x is equal to negative 6. I got to get it equal to 0 first, so we're going to add 6 to each side. Now, when we do that, we want to make sure we do write our problem in standard form, which you can see me doing on the screen. And now I'm ready to do my x in the box. Multiply numbers 72, add to 17, 8 and 9 are the two numbers that are moving on. And we've got 12x squared plus 8x plus 9x plus 6. Going down, 3x in common for those two terms, positive 2 for the second two terms going down, going across, 4x in common for the first two, and plus a 3. So we have 3x plus 2 equal to, and 4x plus 3 equal to 0. Setting each set of factors equal to 0, as you see me writing on the screen. And we're going to subtract 2 to get 3x equals negative 2. And I don't have room to show my divided by 3. That gives me x equals negative 2/3. On the other one, we're going to subtract 3. We got 4x equals negative 3. And again, we're going to divide by 4, which I cannot show because I'm out of space. And we got x equals negative 3/4. And that shows you how to solve a system by using the zero product property of quadratics. Have a great day.